then we'll take questions quickly, and then followed by Prof. All right.
Good afternoon, everyone. My name is Farouk Afolabi. I'm an AI machine learning engineer. I worked on a project titled AI-driven brain tumor detection and segmentation with computer vision, a solution for accessible healthcare in Sub-Saharan Africa. I don't know if we can present. Thank you. So this is the project. The project was built out of the need to build a solution, an AI-driven solution that can help health professionals, neuroscientists to detect brain tumor, right, from MRI scans or CT scans. So can you please go to the next slide? Okay, so from what we can see on the screen, so you can see that in regions, Sub-Saharan Africa or Africa in general, most particular countries like Egypt, Nigeria, and Uganda, we have a lot of cases of brain tumor cases, and we can see that we have about 5,902 per 100,000 population, so which is about 5.96% of the entire population of those regions, which shows we have a very huge population of people suffering from brain tumor related cases. Okay. Next slide. Okay, so for what we can have here, so you can see the challenges we have with brain tumor detection in Sub-Saharan Africa are highlighted. Number one is lack of research. So through my research on this particular project, so I saw that only about 26 articles has been written, and not just only me, so it was also referenced by other researchers who did something similar, so that about only 26 articles on brain tumor were identified in Sub-Saharan Africa between 1960 and 2017, which is a very small, it's a fraction, right? Just a small people who are interested in working in this area. So there's lack of research. And there's also need for innovation, there's need for people to work. I mean, when we talk about Sub-Saharan Africa, we are talking about a region with lower access to healthcare and technology, right? So there's need for innovation. There's also high prevalence of this, like I mentioned previously. 5,902 per 100,000 population is a lot. So there's need for innovation, there's high prevalence, and there's safety impact as well. Next slide, please. Okay, so what did we do? Well, what did I do? So AI role in diagnostics. So AI plays a very important role in diagnostics. I mean, with AI, then we have a lot of potentials as regards to healthcare diagnostics and so on. Then doing that with deep learning techniques. Okay, so the model was built using YOLO algorithm. YOLO is a short form for you only live once. So it is a sophisticated algorithm for image detection, image segmentation, and tracking as well, image tracking. So YOLO is deep learning architecture and was used. Okay, so the model also is used for early detection, right? So I believe that with early detection of this brain tumor, then to aid professionals in mitigating or curing this illness with early detection, and that early detection can be achieved by this model. So also we have improved patient outcomes. So of course, if there's early detection and it really works in the area of detection and early mitigation, then we will have improved patient outcomes. So we also have potential in Sub-Saharan Africa. Yes, it's built based on, it is built with the focus of Sub-Saharan Africa, part of Africa, or Africa generally with low access to technology, poor healthcare facilities. So with something like this, then we have an alternative. Next slide, please. Okay, so yes, this is the YOLO algorithm, right? This is the YOLO algorithm. It's a sequential model or a sequential algorithm neural network infrastructure. So you can see the inputs. The input is going to represent the MRI scans upon which this model will build, the convolutional layers, the CDS. So CDS stands for the convolutional layer joined with a batch normalization, which is an hyperparameter technique, reprocessing technique. Then the silhouettes, what you call the activation functions. So yeah, this is how the YOLO algorithm looks. It's a very sophisticated and very good algorithm, most especially when it comes to image processing, image segmentation, and classification. Yeah. Next slide. So the AI-powered brain tumor, AI-powered brain tumor detection and segmentation model was built based on 3,000 MRI scans. So I believe for people who do not know MRI, MRI stands for magnetic resonance image, right? So of brain tumors of 3 different classes. Okay, so it's built on that amount of data. Then on the detection, the model achieved 92% accuracy on detection. So it did very well on detection and 96% accuracy on segmentation. Yeah. Next slide. So the AI-powered brain tumor model is also, I named it B-scan, right? So that is, it will be able to scan the brain and then detect the brain tumor. And even if there is no brain tumor, it also tells us. So yes, it is also integrated in a web application. So this web application would make it easy for professionals to use. So you just have to just upload the image and then you get the results. You get to see the area, the segmented area where this tumor is found. Can you go to the previous slide, please? Okay, the next one. Okay, yes, this is B-scan. So yeah, B-scan is a user-friendly interface or user-friendly application with tumor detection capability, segmentation feature, support the decision making. It helps those healthcare professionals in making decisions based on the detection and segmentation, that will have been done. And also benefits for resource-limited regions. Yes, Sub-Saharan Africa, most importantly, so will help in detecting brain tumor for early diagnosis. So next slide. Okay, so these are some of the evaluation metrics or evaluation values or scores that has been gotten as a result of this model. Detection accuracy 92%, segmentation 96%, like I mentioned earlier. Intersection over union. So these are deep learning AI terms. So when you are building a detection, machine learning detection model that has to do with detection, so you always have something called intersection over union. So in simple terms, this intersection over union just reflects how well it is able to map out only the area of concern. How well is it being able to just draw out the area where we have the tumor from the MRI scan. Okay, so the previous slide is. So then they recall the precision and the F1 score. So these are all metrics, so which to an extent is very good. Yeah. Next slide. Okay, so a comparative analysis of AI models. So comparing the YOLO algorithm, YOLO V5 most in particular, that's version 5, with other models that were used to do something similar. So we can see that the YOLO V5 did 92% on detection accuracy, 96% on segmentation. Where we can see the other model really did not do well, or if it did well, it is not with a very sophisticated algorithm. Maybe with CNN, for example, which is not as sophisticated as YOLO. Next slide. Okay, so these are the processes that were used in building this application. The first is data collection, about 3,000 MRI images, then the model training, and then integration into web application. Next slide. Okay, so these are limitations in addressing, to address on this particular model, probably something that could be done better in the future. So number one is limitations to current studies. So The model was built based on available resources, right? So for someone to be able to use something that is very sophisticated, you need powerful computers. Okay, powerful computers like GPU and so on, which I do not have, so I just have to use what I have. And yeah, so you can go through that. Then conclusion, so this kind is a good model that will help in proper treatment, taking action, and early detection of brain tumor. Next slide. Yeah, so this is how the brain scan web application look like. So you can see the first, what you have there on the left-hand side is the interface where you get to upload the MRI image. And then on the right-hand side, you can see the uploaded image, which is the MRI scan, the MRI image itself. And then the second one is the segmented image, which segments the area where the tumor is being detected. So that's this scan. Next slide. Yeah, so this is me. Here I am, the AI engineer. Yes, so that's about me. Thank you.
Thank you, Mr. Farouk Olabi. He has been able to present to us in summary MRI scan of the brain tumor to be able to discover, to predict when the patient whether the patient can have a tumor or has a tumor or not. And he was able to use YOLO in his analysis. YOLO algorithm, use YOLO algorithm, carrying out his analysis and prediction. At the same time, he also developed a web application for that we're able to do the scanning as well, predict whether the person has a brain tumor or not. Can we please clap for him again? Are we having one house, please? Sorry for taking our time. So it's time for questions. Do you have questions?
All right, Mr. Olabi, well done. Now, during your presentation, you make mention of the accuracy of your model. Yeah, but I was like, okay, that accuracy, is it on the training set or the testing set? Because for you to affirmate that your model is actually working well, we're supposed to have a validation data. And of course, this validation data too will produce its own accuracy. So which of the accuracy are you talking about? And more also, the data you use, the instances you use, actually up to 3,000. So what is the sharing ratio of your?
Thank you for your question. So the first question was on what part of the data was the accuracy measured. So yes, it was measured on the test set. So and it was splitted on 80-20 ratio, 80 for the training set, 20 for the test set. So 92% accuracy on the test set. Thank you.
Any other question? All right, thank you. Can we quickly move to the second